So the next thing we're going to talk about is operator overloading. Before we talked about function overloading, where we can have like the same name of a function and then change things about the parameters they take. And so you could have like an average function and then overload it so that it'll do different things if there's like 2 elements or 3 elements or 4 elements, however many there are. With operator overloading, we can do sort of a similar process where we can give new meaning to an operator symbol. We have in fact seen this before. The plus sign, we have seen different situations where plus is an overloaded operator that does different things depending on the class or variable type. So for instance, if you're just using the operator plus and you're talking about ints, it will just add the numbers together like you would expect. So for instance, plus, if you do 3 plus 7, it'll give you 10. When we were in string land, plus does an action called concatenate. And my favorite example that I always like to do was to take the string brick and the string house and do plus. And when you do that, it will concatenate them and give you brick, house. So anyway, I loves me my 70s funk music. But anyway, so there you go. So you got brick house. So we can do something similar where we can use the same operator symbols and they will do something slightly different depending on the class or variable type. Other instances where we have actually seen this before, you've got like streaming operators, which are really just less than and greater than symbols. So depending on the context, less than and greater than could sort of mean something different. You can also stream things like floats and stream things like strings. It's the same operators that kind of look like these double arrows. So there are 2 different kinds of objects, but we can still have a stream of information going into or out of the machine, regardless of whether we're dealing with numbers, whether we're dealing with words, whether we're dealing with files, whatever. So here's another example. We haven't ever really used this before, but this is if you put the stream operator on the left as opposed to putting it on the right. So this is a slightly different use of a stream operator symbol. And so here what we do is we have an integer I that we're defining to be 1. And here we're setting int j equal to I. And then we've actually got this same streaming symbol, but this time it is to, it's on the other side of the variable here. It's past the variable instead of being in front of it. And what that actually does is it shifts the bits 3 spots to the left. So this has to do with how the data is stored. So then here, if we actually stream the integer j, this is going to output the number 8. The reason for this is that in binary, the first position is the ones position. If you shift it 3 spots left, that's going to send you over to the position of 2 to the 3rd, because you're going to go from the 2's place, the 4's place, and then over to the 8's place. And so anyway, this is shifting bits 3 spaces to the left. So that is shifting bits, which, if you ask me, bit shifting is a bit shifty, but there you go. The big takeaway from this example, don't think about it too deeply or worry about it if that didn't quite make sense to you. The point is, it's the same symbols, the same pair of symbols, but they do something different in a different situation. And that's really the big idea with operator overloading. What operator overloading does for us is, for one, we don't have to have completely new operator symbols to do different kinds of things for different kinds of variables. We can still do streaming with strings, ints, floats, anything we want. We can do streaming and output them and display them on the console however we like. We can have a consistent set of symbols that does not require an ever-growing number of symbols. It's not like a pictographic or hieroglyphic language where the language needs ever more and more symbols to describe the language that you're trying to get across, as opposed to how a lot of languages work where they have alphabets and you just mix and match the same 26 symbols in different ways. Whoop. And it does not need continuous invention of new symbols. Another example of operator overloading is that less than and greater than can be applied to strings so that you can alphabetize them. Normally, when you do less than or greater than comparisons, you do that with numbers, but there is a way those have been adapted for strings so as to alphabetize things. And by having good overloaded operators, that can improve the usability of a class that we make. And who knows, maybe you can invent a class one day that's so awesome and versatile that people love it so much, it's going to be incorporated into the pantheon of all the great class libraries of C++. Who knows? Anyway, so here are some examples of operator symbols that you've probably seen that we've used a lot of since the beginning here. You've got your different arithmetic operations and also the remainder symbol with the percent sign. I've been talking a lot about streaming, where you stream out and stream in. You've got all your different logical comparisons, less than, greater than, less than, equal, greater than, equal. This one is the mathematically equal, and then this is the not equal. We had Boolean operators, we had and or. We're doing a double ampersand and a double line symbol. These are even more that we've seen. Some of these we've seen, some of them we haven't, but these are more symbols as well. These are all binary operators up here, and what those all do is they require 2 objects minimum to work. So if you're going to do a binary operation with plus, you need 2 things, like a 3 plus a 7. That gives you a 10, for instance. There are things known as unary, or un meaning 1 in this case. And these are operators that actually take a single element. So you can use minus and plus as unary operators, which work a little bit differently. The plus plus operator and the minus minus operator, we've used those several times. Those are unary operators. And then there's also the exclamation point, which is used to mean not. Those are all unary operators. There's even more than that, but these are ones that we've seen, at least in some fashion, before now. So let's overload an operator. We're going to create an operation for division of vending machines. So let's look at that, shall we? So let's see, we've got the same headers we always do. We've got the private members of the class. And then here we're actually making inventory public. Here's our constructor. Here's our constructor with just one variable. Here's our constructor that takes two variables. We've got a number remaining function. So a lot of this stuff is similar to what we've looked at before. So I'm not going to go into a lot of painstaking detail describing all of it. Big takeaway just to note, inventory is on the public side, so users have access to inventory. So here's how you can overload an operator. So the way you do this, you do the class that it's referring to, followed by an ampersand. And then what we're going to do is we're going to say the keyword is operator. And then you put the operator symbol that you want. After that, this is similar to how you define a function. So because it's a binary operator, it's going to take two arguments. Two things are going to be passed to it that are going to be used by this operator. We're going to have an object that we'll call vending machine 1, V1, and we're going to have another object that is vending machine V2. And we are passing by reference here. You'll notice. So if we go back here, we are defining division of vending machines to be the average inventory of the machines. So we're basically dividing the inventory evenly between the two machines. So the way we overload a binary operator is similar to defining a function. So you have the result type, then you do the keyword operator, and then you put the operator itself, which I've designated as OP. So we've got two operands. We're going to have operand type 1. So we've got the type followed by the name. And then the second thing, we've got the type followed by the name. And then inside the brackets, we're going to put the definition of what this actually does. With binary operators, there have to be two operands, one before and one after the operand or after the operator. There will be an end result. A Boolean, for example, should be a true-false comparison. In this case, the type of result, that's basically the same as the return type of the operator function. So what this returns is V1, which is just a vending machine. So that's why the return type is a vending machine. The big difference between operator overloading versus just making a function is that we have the keyword operator inside of it to define it. And then we put the operator symbol after that. And so this is defined just like any function. So this is not part of the class. This is defined outside of the class. So how is this operator defined? Well, we have an integer. We're going to call it total inventory. We're going to set that equal to v1.inventory. It's going to pull the inventory value from v1. Here we've got v2 .inventory. It's going to pull the inventory number from v2. v1 and v2 are both just names of vending machines. We're going to reassign v1 inventory. It's going to be the total divided by 2. And then what we're going to do is we're going to reset v2, and that's going to be the total inventory minus v1's inventory. So we're basically setting it back to the original value because it's going to be the total minus v1. So here, in the main program, we're actually going to do these operations here. I'm going to create a vending machine called lobby machine. The price is 50. The items are 75. Here's another vending machine. This is the break room machine. Price is 50. The inventory is 100. So then before division, we're going to output what the lobby machine has. Before division, the break room machine has. We're going to output that. Then we're going to create a third vending machine. We're going to do lobby divided by break room. And so then after this, we're going to output the inventories of both machines. So created a new vending machine with 75 items. It costs 50 each. Created a new vending machine with 100 items. It costs 50 each. Before, the lobby has 75. Before, the break room has 100. After division, the lobby machine has 87. And then after division, the break room machine has 88. So we have divided up as evenly as possible. There are an odd number of them, but we have divided up as evenly as we could the inventories of these two machines. And so we've essentially taken like sodas or something from one machine and put them into the other machine to kind of balance out their stock. So that is we have redefined the division operator to apply it to vending machines.